Are you ready for trends 3 and 4? Bow! Let's go. All right, so you watched the last video, right? You got atomic radii? You do, right? Over your arrow, you got atomic radii. From left to right, it does what? It decreases. It gets smaller. Fluorine's very small. From top to bottom, it what? Increases. That's trend number 1, atomic radii. Trend number 2, dose, is ionization energy. All right? Now, what happens to ionization energy as we go across? It increases, okay? And as we go from top to bottom, it what? It decreases. All right. Third trend. Here we go. It's called, drum roll, please, electron affinity. Now, affinity, A-F-F-I-N-I-T-Y. Now, if you look behind me, can you see it? It says electron affinity. Can y'all see it on the board? You can't see the board. There we go. Electron affinity. Okay? So, can you see it? As we go left to right, it does what? It decreases. As we go from top to bottom, it increases. So, periodic table, above your arrow again, you're going to write EA, which stands for what? Electron affinity. Okay? EA from left to right is going to decrease. And from top to bottom, I'm going to write EA increases. Show you what it looks like. EA decreases. And on my bottom one, can you see it? There we go. EA increases. Now, electron affinity is kind of like the opposite of ionization energy, which was our second trend. Electron affinity is how much energy is kind of absorbed when an atom decides to gain an electron. Now, if the atom really wants to do it, it's not going to be much energy absorbed. So can you see it? From left to right, it decreases. Why? Because as we go from left to right, you got fluorine. Somebody give it up for my main man, fluorine. This guy wants an electron bad. And I mean really bad. I mean straight thirsty bad. I mean like, what is going on, fluorine? And why are you jonesing for an electron? Well, it really needs it to fill its outer shell. That being the case, fluorine is not going to have any residual energy. All of its energy is going to be used to gain the extra electron. So, electron affinity, the amount of energy absorbed or kind of left over from that process is not going to be much because it wants to do it. Now, as we go down, these elements, francium and radium, they really don't want electrons. They already got enough. They're huge. So there's going to be lots of energy that's absorbed or left over because they have so many more electrons to give over. Do you got it? Do you get it? Good. Third trend was electron affinity. We in this thing. One more trend to go. Here we go. And this one is my favorite. Something called electronegativity. I'm going to move on. Electronegativity. Electronegativity is kind of... Here's the thing. It's kind of a stereotype. It measures the tendency of an atom to kind of jones on electrons. We all know who is the most electronegative. Come on, y'all. Give it up one time for my main man, fluorine. This guy is so thirsty for some electrons. He is the most electronegative. So, since fluorine is all the way across as we go from left to right, get out your periodic tables, you're going to write electronegativity. And here's what we're going to write out. It's spelled E-L-E-C-T-R-O-N-E-G-A-T-I-V-I-T-Y. Electronegativity, as we go from left to right, is going to increase because we're getting closer to fluorine. Everybody that fluorine hangs out likes electrons, needs electrons, gotta have electrons. So, as we go left to right, electronegativity increases. Now, as we go from top to bottom, electronegativity, we're writing this on our periodic table, electronegativity decreases. All right, so I'm going to show you what it looks like on mine. It looks kind of sloppy. Electronegativity increases. See my up arrow? And on the other side, electronegativity, let's see, electronegativity decreases. Do you see it? All right. Now, we know why. Electronegativity, what does it do? It measures the tendency of an atom to really, 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 really like electrons. And we all know fluorine loves them. Gotta have them. So as we go from left to right, it increases. As we go from top to bottom, it decreases. Now it's time for you to do it. Here we go. I got two examples. Can you see them? You got row 1 and you got row 2. Row 1, I want it in order of electronegativity from largest to smallest. Row 1 is largest to smallest. Row 2 is going to be largest to smallest. Pause the video. Pause the video. Pause the video and do it. And I'm going to be back at you in 2 and 2 with the answers. Both rows, largest to smallest, electronegativity. Here we go. And we're back. You had to put them in order of electronegativity from largest to smallest. Okay, row 1 was all in the same period. So from largest to smallest, the largest electronegativity is going to be the one furthest to the right. So it should have been Br, Se, arsenic, and germanium. Again, that's Br, Se, which is selenium, arsenic, and germanium from largest to smallest. Second row, you had the largest to smallest as well, and they're all in the same group. What group? What group are they in? You should know that. Guess what? Alkaline earth metals. We talked about that yesterday. Second group is called alkaline earth metals. We had to go from largest to smallest. The largest electronegativity, the largest one, is going to be all the way at the top. So largest to smallest would be Be, Mg, Ca, and then Ba from top to bottom. Be, Mg, Ca, and then all the way at the bottom, barium. Fourth trend. We in there though. We got it. First trend, atomic radius. And then from left to right, it gets what? Smaller. Second trend was ionization energy. It deals with removing an electron. So from left to right, it gets high because fluorine doesn't want to do it. The third one was electron affinity, which is the opposite of ionization energy. And it decreases from left to right. And then the last one of my favorites, the stereotypical one, is electronegativity. It measures the tendency of an atom to really, 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 really like electrons. Fluorine really does. So as we go from left to right, it increases. Periodic table and trends, turn up Fridays. That's how we do. You know it's coming, don't you? You know what's coming, don't you? It's a worksheet. But you know what? You got it. You got your notebook. You can always rewind the video. I believe in you. Yes, you will learn today and all that good stuff and pass the chemistry SOL. So turn up, get those worksheets done. Be sure to use your notebooks. I don't mind you working together. And be good. Miss Baldwin loves you. I'll see you Monday. Bye.